I'm late to the class. Okay. Yeah, thank you. I know that's you.
Yeah.
Hello everyone. Hello. So last chapter, last day. Yeah, exactly. I was so tired today. I wish I could cancel the class. I cannot.
You could.
Huh?
You
I
could.
could. I wish. I have a really horrible headache. Like, so awful. I cannot because last chapter, last week, and then we should finish the chapter. Okay, so chapter 11. Actually, half of this chapter is not that difficult for you. We already talked about exponential function, and we saw most of these relations. Do you remember? So power if we are multiplying a base power m, multiply a base power n, base are the same, so we add the powers. And then if we are dividing them, you will subtract the powers. And then if you have two powers, you multiply the powers. And then here also, if you have negative power, you can write it down in this form. Okay, AB power n also, n belongs to each of them, so that's why you have a power n, b power n. And here also, if you have b divided a power negative n, we can use reciprocal of b over a, which is a over b power n. And then as you see, we change the sign of the power. So we already know about exponential. Now it's like exponential function. So whenever we have something in this form, f of x, we call this function. So it means whatever value you give to x, you will replace it here and you can calculate it, and they will say you are evaluating the function at this point, at this x. And actually f of x is y itself. So either you could write it down like y equal b power x, or you're writing down f of x equal b power x. These both are the same.
So, are you saying that f of x and b power of x are like the same thing?
Huh?
F of x and b power of x are the same thing?
No, I'm saying these two are the same thing.
Oh, I was like that.
Well, as I said, you can evaluate this function at any point. So, for example, if your function is f of x equals 4 power x, you can find x at, for example, 1. F of x at 1. In this function, evaluate this function for x equals 1. So what that means instead of x here, you will put 1. So as you see, for x, I put 1 here. For x, I put 1 here. And then 4 power 1 is 4. So you will say f of 1 is 4. You have evaluated this function at 1, at x equal 1. And the result is 4. And then we can show function with different letters, like g of x is also a function. We define the function as g of x. Here we define the function as f of x. So for this one also, if I tell you, let's calculate or evaluate this function at 2, means instead of x you should put 2. So now you should know, if you have a fraction like this and the whole fraction has a power, so we say numerator has this power, divide by denominator has this power. So that power belongs to numerator and denominator. And then you can say 16 divided by 81. So for different x, we can calculate, we can evaluate either of this function. So even here it says, let's calculate each of these for x equals pi. Means instead of x here put pi, So you are going to calculate 4 power pi, right? Which is like you have to use calculator, right? In calculator also you have pi. You can say 4 power pi is something using calculator. Okay, so graphic, or what do you call that? Graph of these functions, exponential function. So, oh, look at this. It says y equal to power x, right? So that's why I said either we can have f of x equal to power x, or we can say y equal to power x. So both of them are the same. Look, either we can say y equal to power x, or we can say f of x equal to power x, because f of x is equal y. Do you understand this? So these are both the same thing, exactly the same thing. Okay, so if we have 2 power x, if we want to draw a graph for that, we will find y for different x, right? Do you remember how we draw a graph? A linear graph also, what we do? We find 2, 3 different points, order pairs, do you remember? And then we draw a graph. So here also, we will do the same thing. Let's say we have 2 power x. For x equals 1, 2 power 1 is equal to 2. For x equal to y is 2 power 2 equals 4. And then you can actually calculate for x equals 0. Y is equal to 2 power 0, which is, do you remember what is 2 power 0? 1. Oh no. 1. Forgot. 1.
1.
Yeah. 1. Correct? 1. And then for x equal negative 1, y is equal to 2 power negative 1.
1/2.
Mm-hmm.
Oh, because it's that formula, the reciprocal.
Exactly. And then x equal negative 2 will be y equal 2 power negative 2 equal to 1/4. Exactly. So we had 5 different x value, 1, 2, 0, negative 1, negative 2. For each of them, we calculate y. So we have 5 order pairs, right? One order pair is 1, 2. Another order pair is 2, 4. This is x, this is y. Correct? And then another order pair is 0, 1. Negative 1 and half. Negative 2 and 1/4. So we have 5 order pairs. So using these order pairs, imagine, okay, this is 0, 1. We have it. 1, 2 also. You see that here, right? And then for x equals 0, y was 1. And then 2, 4 also, we have 2, 4, right? We have this one. And then let's see, negative 1. Okay, this is x equal negative 1, right? And then y is half, right? And and then x equal -2, this will be smaller. And then if we continue, imagine for x equal -8, y is 2 power -8, which is 1 over 2 power 8, right? Which is very small. Do you know that when denominator increases, the whole thing becomes very small, right? So that's why. So it becomes very small, very small, very small, and that's the reason y becomes very small when x is increasing to this side, like -x. So any power function, like exponential function you want to draw, if this power is x like this, form of graph would be exact same as this one in this form. But if base is greater than 1, you will always have this form. Base is 2 now. 2 is obviously greater than 1. Now if the base is some number between 0 and 1. Now we want to see what happens if our... Come on. Really? You're so happy. Okay, so let's see what happens when we have 1 over 2. We want to try this for different x value, find order first, right? So we'll start with x equal 1, y is 1 over 2 power 1, which is 1 over 2.
Are you just inputting in a random x?
Yes. And let's say x is equal to, y is half power 2. What is half power 2? 1 over?
2 over 4.
1 over 4. Right? Because it will be 1 power 2 divided by 2 power 2. Am I right? Correct? Then x is equal to 0. 1 over 2 power 0 is 1, right?
Yes.
Correct? X is equal to -1. Now, y is equal to half power -1. No.
Negative
2
1.
power positive 1. So reciprocal. This becomes reciprocal, right?
So 2.
What you said? You said the same thing?
2.
So look at this. I showed you in a formula. A divided by B power -n is reciprocal.
2 over
Okay, you were right.
2 over 1.
Louder. Next time you should say that.
So it's 2 over 1?
Yeah, 2.
That's what I said that too.
So 2 is 2 over 1.
That's what I said.
So you could say after I say 2.
I said 2.
It's correct?
Okay.
Okay. So reciprocal of 1 over 2 is 2, and then the power becomes positive 1. So now try this one. tell me.
4. Wait, why is it 4? 2. Oh, just kidding.
So it will be 2 power positive 2, right? Is that correct?
Yes.
Which is 4. Okay, so, let me write down the order first. For this one, we have 1 and half. For this one, we have 2 and 1/4. For this one, we have 0, 1. For this one, we have -1, 2. For this one, we have -2 and 4. So the difference between this one and the previous one is this. Here we have reciprocal of that 2. That previous one, base was 2 and 2 is a number greater than 1. But this one is half, and half is a number between 0 and 1. And look, the shape has changed. And now it's this form. So if the base is a number between 0 and 1, the shape of graph becomes like this. And if you check, we have all the points. 0, 1 is here, -1 and 2, we have it, -4 and -2 and 4, we have it. And then from here, when x increases, the y value decreases. Do you see that? So the y value becomes smaller and smaller. So let's compare this to when we have y equal to power x and base, which is 2, is a number greater than 1, shape of graph is like this. And then if we have a base between 0 and 1, like it mentioned here, 0 and 1, shape of graph is like this. So they are kind of opposite of each other. Mirror image to y-axis. Is that correct? These two are mirror image to the y-axis. Means they kind of transfer.
Yeah.
Yes. So this is the Okay, so now we want to solve exponential function using different rules. So one of these rules says, listen. One of these rules says, if we have an equality on the right side and left side, we have exponential functions. Both of these exponential functions have the same base. The power is just the power is different. So what happens? They cannot be equal unless their power is exact same. Like I cannot say 2 power 5 is equal to 2 power 7, right?
Yeah.
I cannot say such a thing. This is true if 2 power 5 was equal to 2 power 5, right? So it's true if the powers are the same. So that's why it says if we have y power m equals y power n, m has to be equal to n, right? No?
Why wouldn't they be m and n, not m and n? Why wouldn't they be the same letter if they were the same?
So they are saying they have to be the same, right? If it was m, we are not solving for anything, right? if these two are different, at least we have an aim to do some math and solve and find the unknown.
Okay, but okay, just go.
Okay, you know why? Because, for example, this m can be 2x plus 1, and n could be, let's say, 3x plus 2, right? They don't look similar, do they? So that's why they have different names. They have m, they assign m to this one, n to this one. And now let's use this exact same thing. So I have y power 2x plus 1. Actually, let's write down just a number. P, then 3 power 2x plus 1 equal to 3 power 3x plus 2. So one was m, another was n, right? So now how I can solve this for x using the rule and say, I know they look not similar, they are not, similar, but they have to be similar, right? They have to be similar according to this rule. According to this rule, the power has to be similar. So we will say, okay, according to this rule, 2x plus 1 has to be equal to 3x plus 2. Now solve this. Now we have unknown. Our unknown is x, and we are solving for x, right? So now you can solve it because you have just one variable x, right? So what you do, you will bring all the x value to one side and constant to the other side to solve it for x. So you will have 2x minus 3x equal to 2 minus 1. Am I right?
Yeah.
And then
b1 minus. Oh no, you put the bigger number in front of the.
I brought this to the other side, and then bring this one to this side.
Oh, okay.
So we have 1x equal 1, x is equal to negative 1. Am I right? So now you understand what is the aim of doing this and not having m and n, m and m. So now it says this is true whenever x is equal to 1. Can we prove that? Just put that, negative 1. Put that negative 1 inside this and then see if it works. So for x equal negative 1, we want to check this, right? We will say 3 power 2 multiply negative 1 plus 1 is equal to 3. So we have 3 power negative 2 plus 1 equal to 3 power negative 3 plus 2. 3 power negative 1 equal to 3 power, it should be negative 1. So as you see, with x equal negative 1, this equality is true. So we use this rule to find the unknown in power in this situation. My example was almost saved. I didn't see that, I promise I didn't see that. It just came to my mind. I just said 3 and It looks similar. I got just, negative. Okay. So let's solve this. Listen. What's wrong today? Okay, let's solve this. Okay, we want to use the same rule. Okay, how can we use the same rule now? The rule says bases are the same, powers are different, but we know for sure power should be the same, right? So we will start with the same base. Make these two sides, or change either of these to the same base as the other side. Like 81, can we change it to 3 power something? We should. 3 power 4, right?
Yeah.
3 power 4. Because 3 power 2 is 9. 9 multiplying 9 is 81. Okay? So 3 power 4. So instead of 81, we are going to write down 3 power 4. Why? Because we want to make these two sides to have the same base. The base is 3, right? So that's why I will write down 3 power 2x minus 1 should be equal to this. So now the bases are the same. Powers are different, but we know for sure these powers have to be the same, right? So we set these two powers to be equal, right? So this power should be equal to this power. And now what we do at this point?
Add 1.
Solve for x. Add 1 to both sides to solve for x. Exactly. 5.
So why did you use 4?
Why did we use 4? Because 3 power 4 is 81.
Oh.
Yeah. So what will happen if I put 5 over 2 here? If I put back 5 over 2 here, gives you 4. Because these two powers should be the same. So 5 over 2 is the only case that give you the same power as this one, right? Good. So in this way we are solving an exponential function. We are solving exponential equation. So the next one. Power negative 3x minus 2 is equal to 36 x plus 1. 36 power x plus 1. So the first thing we do here is to have the same base on both sides, right?
Yes.
We will start with 6 because we have 1 over 6 here, right?
Yeah.
So if I change this 1 over 6 to 6, what happens to the power? What is that? Exactly. It will have another negative sign outside, so everything becomes positive, right? Because 1/6 power negative 3x minus 2 is equal to 6 power negative of negative 3x minus 2. Am I right? Now we should know that. Reciprocal of this one, change the power to negative or positive, different sign, right? So let's look at this. So let's say we have 1/6 power negative x, negative u. 6 is power
6 power
u, correct? So imagine u was negative 3x minus 2. So we have negative of negative 3x minus 2. Okay. Are we good here? You know what we did? So I will put that here. We have 6 power positive 3x plus 2, right? Equal to, okay, now 36 is 6 power 2, right? Is that correct? Yes. So 6 power 2. Correct? And then if I have a power m power n, do you remember what we do?
Multiply m and n.
Right?
Yeah.
So use this. You are multiplying 2 to
X plus 1.
x plus 1. Right? So we'll have 6 power 3x plus 2 is equal to 6 power 2x plus 2. Exactly. So what is the next step? This one has to be equal to this one, right? This power has to be equal to the other power because the base are same. And then we solve for x. 3x plus 2 has to be equal to 2x plus 2. Can I cancel 2 from both sides?
Yeah.
Because it's similar, right? So 3x is equal to 2x. How we solve it?
It's x equals 2 over 3.
Subtract x from both sides.
Subtract just x from both sides or
2x.
subtract 2x? Okay,
2x.
let's do this. Subtract 2x from both sides.
And then you get 3x minus 2x equals 0.
And then what happens? 1x is equal 0, right?
Yeah, and then you divide.
Divide by
1.
Okay. So divide by 1, you will get x equal
0.
0. So x equal 0. So just in this case, if x is equal 0, this both sides will be the same. So our equation was this one, right? This was our equation. This was our equation. So I want to replace x equals 0 to see what I get. Okay? For x equals 0, 1/6 power negative 3 multiplies 0 minus 2 equal to 36, 0 plus 1. Right? 1/6 power what? Negative 2 equal to 36 power 1.
And then you do the reciprocal fraction.
Uh-huh. And then we will have 6 power what? Am I right? 6 power 2 equal to? Is this correct? Why?
Okay, never mind.
So it was true. For x equals 0, this equality is true. Right? Do you have any question? Question? No.
Can you, instead of using the original equation, can you use like the 6 3x plus 2 equals to 6 2x plus 2 equation to make it more simpler?
Yeah, of course. And when we want to check it,
Yeah, we were
oh, of course, you can do that. Yes. So, what was that? The second step or third step?
third step.
Third step. What was that? 6 power
3x plus 2
3x plus 2
equals to 6 2x plus 2.
6 power 2x plus 2.
Yes.
Yeah, look. This was the simplified form, right? So we want to write down x equals 0 to see what happens. So we have 6 power 0 plus 2 equals 6 power 0 plus 2, which are exactly same, right? So 0 is answer for this equality in any steps. If we simplify that before simplification, it's the same. Okay, so the next question, actually I want to change a bit of it. Instead of E, I want to write down Y. Maybe something else. Maybe like this. You have u power x, u power 2 equal to u power 4 divided by u power x plus 1. We have a multiplication on the left side of equality, and we have a division on the right side of equality, right? If we multiply two terms which have the same base, these bases are the same, right? Both of them are u. So we can write down one of these, and then what happens to the power? Add them, exactly. Right? You add them. X plus 2. Right? And then on the other side, you have a division. Base are the same. We can write down one base, and what happens to the power? Subtract. Exactly. Right? We can write down 4 minus x plus 1. Right? Right?
Sure.
Is this correct? Okay. So let's simplify that. u power x plus 2 is equal to u power 4 minus x minus 1. Right? Right?
Yeah.
Yes. So we have u power x plus 2 equal to u power 4 minus 1 is 3. 3 minus x. 3 minus x. So now, can I solve for x?
Yeah.
How? Exactly. So from here, because bases are the same, we say x plus 2 is equal to 3 minus x. Did I do any mistake anywhere, somewhere? Oh, okay. Yeah. So this goes to the other side, right? So we have x plus x equal to 3 minus 2. 2x is equal to 1. X is equal to 1 over 2. Correct? So now this one will be the last section. Is that?
Is it 11.3?
11.2. Oops, no, I'm sorry. One more section. Okay. We want to use all this information and explain the logarithm. It says logarithm, base b of a positive number x is the power or exponent to which the base b must be raised to produce x. So it means if we have y equal to log with base b, log of x with base b, we call that base b, is the same as x equal b power y. B has to be positive and not equal to 1. So, if we have x equal b power y, and now you know this is exponential function, this will be exact same as y equal to log of x base b.
I hate this.
Me too.
That's not nice.
I hate
To log it. B is base here, right? This x is coming from this side of exponential function. This y is the power of exponential function which goes here. So there's a relation between this logarithm and exponential function. For example, if I have x equal to 2 power 3, this is exact same as 3 equal to log with base 2 and x goes here. What is 2 power 3?
8.
8. 2 power 3 is 8. 8 goes here. 8 goes here. So, using this relationship, now you will understand that log 8 base 2 is equal to 3.
So it's basically the answer is equal to.
Answer is equal to power of exponent. Right? Do you get that, the relation? So, I think for the first days, if you're working, you have to have this with you to replace everything. Like here, I would write down, okay, this one is y, and then this one should be y. This one is b, this one is b. This one is x, this one is x. So, if I ask you to tell me what is the logarithm of can you tell me?
2. No. Hold on. Yeah.
Wait.
Sorry.
Think and then raise your hand to see if you got the correct answer. You got it. What is that? 2.
I said 2.
Did you?
Yeah. Remember, I was like, yeah, y is 2, and then. Yeah, I did.
Okay, next time raise your hand or say it in a calm way, then we can understand.
Yes, ma'am.
Okay? So, do you understand what happened? If this was 2, then we could say 2 power 2 is 4. Because here we said 2 power 3 is 2 power 3 is 8. Really? 2 power 3 is 8. So that's why. So now let's see if you got this. Y is equal. Raise your hand, be quiet, and then answer my question. Log. Do you know that? Or is that show me with your fingers? Yeah.
Yeah, it's 100. Or is it 10? No, it's not 10. It's not. It's
Oh, actually, I think you don't know what. Okay, do you have the answer? Do you know what's that? What is that? 100? So you think 10 power 100? She said 100 too. You said 100 too. So you think 10 power 100 is 1,000? Huh?
10 power 3.
You use your phone. Cheating. 10 power 3 is 1,000.
Wait, really? Wait.
You didn't know that?
10.
That's so easy.
Dot.
Wait, I still don't understand.
10.
Because you were working with your phone.
There's 3 zeros and 3
Now you understand 10 power 2 is 100. 10 power 3 is 1,000. 10 power 4, you will have the number of 0 front of 1, right?
Yes.
Wait a minute. 10. Wait. 10 times 10 is 100.
Yeah, 10 times 10 is 100. 10 times 10 times
100
10
times-
is 1000, right?
Yeah.
Okay.
So it's 3. Oh.
It would be 3, right?
What's when?
So here, 10 power 3 is 1000. Okay, so now I will change it in the other hand. Okay, so now what is x? What is x? Do you know that?
Oh, I know.
Yes, but actually, minus 4 or 4 or something else.
It's not 1/2. Is it?
1/2? Any idea?
It's not 1/2.
What is that? 1/4. Right?
Oh,
1/4.
I was close.
1/4. So
It's positive.
2
right?
power negative 2 is 1 over 2 power 2, which is 1 over 4. So x is 1 over 4. So do you hate logarithm now? Still? You don't have emotion. We had fun. It's a puzzle, kind of. Okay, another question. Let's see. So for this one I want y, and for this one I want x. So let's see.
Wait, you want x for that one and then y for that one?
What is x?
I don't know.
Hmm?
Is it 25?
Exactly, 25.
Because 5 squared.
Mm-hmm. Exactly. Correct? And then what about y?
Negative 9.
Negative 3.
Negative 3.
Negative 3, right? Negative 3. Because 3 power negative 3 is 1 over 3 power 3, which is 1 over 27. Correct? Okay, do you have any question? Did you understand this? Good. Good. Oh, this is good. Oh, one more question. I have one more question. Yes? Oh, that was good. Yeah. So,
Oh, because 2 to the power of 0 is 1.
2 power 0 is
1.
1, right? Okay. So if you know this now, you should easily tell me what is log, for example, 2. Huh? Is that correct? 1. Do you understand this? So this is actually a logarithm rule. So if we have y equal log of a, base a, actually let's write down b, sorry. B, base b, so y is always equal to? Come on.
A. I mean,
1.
1.
I just said this is a rule. I just said this is a rule. So y is equal to 1. If this one and this one is equal, y is always equal to 1. So this is one of the rules. Okay? And this one is actually another rule. Okay, so this one. So this is equal to 1 always. So what about this one? Log 1 base b.
1.
0.
0.
Oh my.
B power 0 is 1, right?
Yes.
So, correct? Oh. So, look at this one. 2 power 3 is 8. This one. Log of 10. What is the base here? Log of 10, we don't know the base, is equal to 1. So base should be equal to?
I mean, 10.
Base is 10, right? Because 10 power 1 is equal to 10. So from now on, you should know that if you don't see any base for log, the base is always equal to 10. It's not, forget about 1 or whatever you see. I'm saying any logarithm you see, log 2, log 5, any logarithm. If you don't see any base here, the base is always equal to 10, always. So like the, what is that? Radical, do you remember? We said if you don't see any index, index is always equal to 2. So here for logarithm also, if you don't see any base, the base is equal to 10. Okay, 10. And then ln is also a logarithm, but it is a natural logarithm. This natural logarithm, if the regular logarithm has a base 10, the natural logarithm has base e. So ln is the natural logarithm with base e. So ln is a logarithm with base e. So look at this one. So E is a constant and it's equal to this number here. 2.7182, 81, 82, and actually it's continuing. So the E you see is just a number, the constant, and the number is equal to this one. So instead of writing down all these numbers, they are using this, they call that E, and then they said, okay, when logarithm has a base E, we call that natural logarithm. This is actually, it has lots of application in physics, in architecture, everything. So whenever you see ln, means that it was a logarithm with base e, and e is this number, 2.7182, and yeah, as you see here also, log x is equal to log x base e, and we call that natural logarithm. Okay. So natural logarithm also can be solved using logarithms properties. So if we have ln 1, this has to be equal to 0. Why? Because there was a number e here as a base, right? So e power 0 is equal to 1. That's why. And then if we have ln base e, so what is this equal to?
10.
So this number,
0.
power, exactly, power 0 is equal to? Oh,
1.
no,
It's
no,
equal to
this
1.
is 1. This is 1. You said 1, huh? That's good. Good job. Do you have a question? Sure? No question?
Wait a
So you
minute.
got it.
Wait, if oh, just like with that B formula, if both
B formula is there.
yeah, I know. So it's
Yeah,
just
if
like
both
the
of
same
them
thing.
are the same, it will be 1. Okay, do you have any question? Okay. So I think the rest of these we already have lots. So look, 10 power 3 is 1000. So let me see. Yes, okay. Next time we will go through chapter 11, section 3, which is really important. important. I mean, that's the main part of this chapter. Any questions? No? Okay. So we'll see you on Wednesday, and that would be a last lecture before your exam. Okay? Study for the exam.
Is our exam based on homework?
Yes.
It's based on like the homework and the quiz.
You too, you talk too much.
I don't talk that much. You talk to me. Yeah, it's not me.